Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Monder. Today, inshallah, I'll talk about signed fixed point numbers. We have four things that we need to talk about. So, we're going to talk about the signed magnitude and the ones complement, twos complement, and after that, we're going to talk about axis-based complement. We're going to talk about two complement, the nines complement, and the tens complement, inshallah. So let's start with the sign magnitude complement. When we say sign, that means that we have a positive number and negative numbers, and these are implemented in binary based system. So basically, we are looking at the most significant bit in the number. If the most significant bit is 0, that means the number is positive, and if the most significant bit is 1, that means the number is what? The number is negative. So how do we implement number using this way? So let's take an example. For example, we're going to say that we have a number, let's say 25. Okay, 25 is a decimal number. In binary, it is equal to what? In binary, it's equal to, let's just put another sign to get over it, this one here. So in binary, it is equal to what? It is equal actually to, let's say 1 1. Let's put it in separate cells, 1 1 and 0 0 and 1. I'm sure that you know how we convert number. I'm gonna make it like same bits. If you want to make it 8 bits, that's fine. Let's make it 8 bits. So if we want to make it an 8 bits, we're gonna just add the 3 zeros in front of it. So we're gonna say 0 0 0, and then we're gonna say 1 1 0 0 and 1. So let's just make it 8-bit. This is now the most significant bit here is 0. Okay, that means the number is what? The number is equal to actually plus 25. So this is the number. Okay, but how we implement the minus 25 number? Okay, now this is different system. I said we have to put the most significant bit to indicate as 1 to indicate that the number is negative, and then we can leave the rest of the number is the same. So we can say 0 0 1 1 0 0 1. So this is equal 25. You can see that the number is the same bits. Actually, it's the same bits in each number as a binary implementation, but the difference only on the most significant bit, which is the first bit in the number, we can say. Okay, the most important bit in the number. So this is a positive, is because it's 0, and this is a negative because it is 1. So we're going to talk about this. So if we talk about, for example, let's take the 0, you can implement the plus 0 here as this number. So the plus 0 will be as an 8-bit digit, 0 0 0 0 0 0 0 0. This is 8-bit. How about the minus 0? The minus 0 will be exactly the same, except that the first bit will be 1 and the rest of the bit will be zeros to indicate this is the plus 0 and this is the minus 0. However, we can say look at the also plus 127 and the minus 127 as an 8 bits, and we can represent that as well. So the numbers or the digit will be the same. The only difference is the last bit, which indicates 0 as a positive and 1 as a negative number. However, sign magnitude representation is not really used, in the ALU. So most of the ALU or CPU now are using the two's complement. Okay, now we're gonna move and talk about the ones complement and the two complement in a simple way. Okay, so I'm gonna move to down here and talk about the ones complement. We're gonna ones complement. and we can write it this way: ones complement. The ones complement basically is replacing each 0 with 1 and also replacing each 1 with 0. So this is a very simple way. So if we have a number like this, for example, we can represent in binary. So we have 3, for example, as a 4-bit, 0, 0, and this is 3. And this is, if we want to take the first complement for it, okay, if we want to take the first complement for it, then we're gonna say, for example, it will be converting the ones to 0 and the zeros to 1. So the first complement will be moving to like 0. This one will be 0. This one will be 0. This one will be 1, and this one will be 1. So we can understand that this is equal to plus 3, and this one is equal to minus 3 in the ones complement, okay. Basically it's a very simple way that we can convert each one to 0 and each 0 to 1, okay. Now the twos complement, okay, twos, so I'm gonna talk about the twos complement directly, and then we can take an example. So we're gonna say twos complement. We can write it this way: 2's complement. So the 2's complement basically can be obtained by 2 steps. Step 1 is taking the 1's complement, and step 2 is by adding 1, let's size it as 1 like this, to the least significant bit. We're going to talk about that and take an example. Least significant bit. This is step 1. Okay, this is step 1, and I'm going to just put 1 here. So let's take an example right now here. For example, let's take the 3 as an 4-bit. You can take it as an 8-bit if you want, or 5 bits, but let's take it as 4 bits. So we're going to take 3 plus 3 is equal to, actually, plus 3 is equal to what? Is equal 0, 0, 1, 1. Okay, I'm going to make it separate here, 0, 0, and 1, 1. If I want to take the 2's complement, first I have to take the 1's complement, which is basically equal to what? Converting the 1's to 0 and the 0 to 1, and that will be 1, 1, 0, 0. And then I'm going to add 1 to it, so I'm going to put plus here. So the plus will be, let's say, add, like this, and then we can say add 1 to it. So I'm going to add 1 here. So the result will be, now 1 plus 0 is 1, and here we have 0, and here we have 1, and here we have 1. So that means this is the minus 3 here in the 2's complement. So this is the minus 3 in 2's complement. All right, I hope that you guys understand the difference between ones and twos complement, and how we can convert a number into ones complement, and how we can convert a number into two complement. As a summary, one complement is by taking the 0 and replace it with 1, and taking the 1 and replace it with 0. The 2's complement can be taken by, first we're going to take the first complement, and then after that we're going to add 1 to the least significant bit, and the output will be the 2's complement of the numbers. I'll see. After we talk about the first complement and the second complement, we have special cases in the two's complement that might be considered as inappropriate or incorrect result. So for example, we have the 0 number, okay, which is basically as an implementation in the first complement is equal to what? Is equal to 0, 0, 0. Let's take 8 bits, 0, and then 0, 0, 0, 0. This is 8 bit. Okay. If I want to do the first complement for the 0, which is the minus 0, and that will be converting it into 1. So it will be 1, 1, 1, 1, 1, 1, 1. So this is in the first complement. Okay, this is in the first complement, and we don't have any problem in this. Okay, now if we talk about the first complement right here, that's not a problem. Okay, but if I want to talk about the 0, I want to consider the second complement and converting the 0. Let's say this is the second complement, and I'm gonna make it red so you can see it. So this is the second complement. When we said we take the second complement, we take the first complement and then add 1. So we're gonna add 1 here to the first one, and the result will be actually something like this: 0, because 1 plus 1 0, and you have 1 carry 0, so 0 0 0 0 0 0, and you have a carry. The carry will be 1. Okay, this is the carry, so I'm gonna make it a different color, but this is the carry. So you can see that is that in a 2's complement, minus 0 is actually the same as what is the same as plus 0. Okay, there's no difference between them, they are equal, and this is inappropriate. Okay, this is inappropriate, that we can see that 0 in is equal to minus 0. This is the first case. Okay, we can say we ignored this one because it's overflow, so you can see that minus 0 is actually not equal to 0, but in 2's complement it happened like that. So we're going to say this is a special cases in 2's complement. The second, let's talk about another case, which is case number 2. Let's take the number 128. 128 in binary is actually 1 and 0 0 0 0 0 0 0. This is 128. So if I want to convert it into the first complement, I'm gonna just convert the I'm gonna convert the ones to 0 and the 0 to 1. So that will be 1 1 1 1 1 1 1, and this one will be 0. Okay, so this is represent like in 2's complement, it represent what? It represent the minus 128. Okay, now let's convert it into 2's complement. If when I convert it into 2's complement, I have to add 1 to the number, and the result will be the same as the 0. So the result will be 0 0 0 0 0, because when adding 1 0 0, and then we have 1. Okay, so what happened that now is that the 1 minus 28 in the 2's complement minus 128 is actually equal to plus 128, which is the another special case that is inappropriate result, and you can say it's we can say it's overflow because it's not really correct. Okay, so this is the second case. Okay, but there is no 128 because the numbers is goes from minus 127 to plus 27 to plus 127. We can see that there's no 128. Okay, so this is value is actually any minus 128 values is overflow. Okay, so these are 2 special cases that considered as an overflow in the 2's complement. I hope that clear enough for you guys.